We're going to be doing systems of linear equations in two variables today. We're going to be doing systems of equations for this whole chapter. Today we're going to start with the small ones. They've just got two equations with two variables. And they're linear, so there's no squares or square roots or anything like that. They're just going to be equations where they're nice and simple to work. So we've got checkpoint 1. My two equations in this problem are 2x minus 3y is equal to negative 4, and 2x plus y is equal to positive 4. Now, on this particular example, all they want you to do is decide if these two points here happen to be solutions to this system of equations. So what does it mean for something to be a solution to the system of equations? Do y'all remember this at all? From Algebra 1, Algebra 2? Yes, if you plug a solution to any equation means that if you take the point, because the first coordinate of the point is the x and the second coordinate of the point is the y, and if you plug it in an appropriate place, it's going to make the statement a true statement. Because if it doesn't, it can't be a solution, right? That's what a solution is. It's the stuff that gives you true statements, or it makes our statement true. So we can try the 1 and the 2. So I've got 2 times 1 minus 3 times 2. And my question is that equal to negative 4? So that's 2 minus 6. Yes, it is equal to negative 4. So it works for the first one. But remember, this is a system of equations. So for this to be truly a solution to the system, it not only has to work for one of the equations, it has to work for both of the equations. So I got to check my other equation here. So I've got 2 times 1 plus 2. And the question is that equal to 4? Is equal to 4. So the point 1, 2 is a solution. Now, do we need to check this other point to see if it's a solution? Think about this for a minute. What shape is this when you graph it? It's a line, right? And what shape is this? It's a line. So, but we don't care if it falls on either line. It has to fall on both lines for it to be a solution. And if we already have a solution, and these are definitely not the same lines, right, because they've got two different slopes because of the coefficients in front of x and y are different. Everybody following what I'm saying? And then one's not a multiple of the other. Think about a line. If I've already got a place where these two lines intersect, is there going to be another place where they ever intersect? No, because they can't curve around and come back over, can they? It's not a line then. So is there any need to check B? No. We can check it if you want to, but it's not going to work, right? Is anybody not listening to what I'm saying and working ahead and found the place where it doesn't work yet? Yeah. So which one doesn't work? The second one. The .76 doesn't work in the second one. That's exactly right. Good. All right. Now, the rest of this section is about how, not if I give you a solution, can you tell if it's a solution? But can you just find the solution from scratch? And there are a couple of different methods that we're going to talk about in this section. One is the substitution method. And I'm going to tell you that there's not one particular method that's better than another. There are instances where one method works more nicely than another. But hear what I just said. Substitution means exactly what it sounds like it means. I'm going to take something and substitute it in something else. So the substitution method, the only time that I would tell you to use the substitution method, if they're both linear, is if one of the equations has been given to you solved for a variable. Okay? So an example that you might have that looks like that, and they don't even do it. Their checkpoint 2 I would never even use this for an example for this. Okay. Although this isn't a bad one to use for the substitution method. I have one variable sitting here that has a 1 for a coefficient. Everybody see it? This one right here in the second equation, the y. So I can take that and I can solve that and make that y is equal to negative 2x plus 1. Now I'm going to tell you, if it was a test, the only time I would use the substitution method is if they had given this to me so that this one was in this form, the top one was just like it was, but the bottom one was already solved for a variable. That's the only time I'd use substitution method, if it was already in that form. I wouldn't solve it to that form. Now, what you do, the reason that you would use the substitution method here if it were in this form is because I know what y is equal to in this equation, right? Negative 2x plus 1. So if I want to find the place where these two lines intersect, then I can take that expression and stick it in for the y in the other equation. And that's going to find for me that point where they're both there at the same time. Because I've taken one and put it into the other. So I've kind of made one big equation with both of them. Everybody hear what I just said? I'm going to make one big equation that uses both of these two equations. Okay? So this is going to become 3x, right? I didn't do anything with it. Plus, and there's my 2. And behind 2, instead of writing y, I'm going to replace y with the negative 2x plus 1 from the other equation. Kind of exactly like that. It's a composition of functions is what we do here. It's exactly right. Okay? Same idea. Now, see, I've got this one equation that's made up from the 2 that I had before, but it's just got one variable in it. So now I can solve this like my old way of doing it, right? Do the distributive property, so I got 3x plus negative 4x plus 2 equals 4, right? Then I combine like terms, so I got negative x plus 2 is equal to 4. Subtract 2 from both sides, so negative x is equal to positive 2, so x is equal to negative 2. Now, that's not all of my point though, right? My solution is a point. What do I have of the solution? The x-coordinate. What do I need? The y-coordinate. So can you look here on my screen that's showing here and tell me what I can use to find the y? Everybody see this one right here? It tells me y has got to be equal to negative 2 times whatever x was plus 1. So I can go back to that equation and I can say, well, then y is going to be equal to negative 2 times negative 2 plus 1. So that'll be positive 4 plus 1, which would be 5. So my ordered pair that is my solution is negative 2, 5. Okay? Anytime you do substitution, that's what you'll want to do, is you'll want to go back to that one where you solved it for the one variable or it was already solved for a variable and plug the one back in that you just found. There are three distinct steps. You have to substitute in and solve for the first variable. That takes 2 steps, the plugging in and the solving. And then you have to plug it back in to one of the 2 equations to find the other variable. It doesn't really matter which one you pick to plug it back into. It's just nicer if you use this one because it's already solved for y or x, whatever the case might have been. Any questions? Y'all think y'all got substitution? All right. The next method is called the addition method or the elimination method. Well, this is actually number 3 because the first one was just talking about what a solution to a system looked like, remember? So this is actually objective 3. Okay. It's called the elimination method in a lot of places because you eliminate a variable. It's called the addition method in a lot of places because you do that by adding them. Okay, so it doesn't really matter which one you call it. A process is the same. What you're trying to do with this is you're trying to find some way so that when you add the numbers together, something gets eliminated. So, I've got us an example here. So I've got 4x plus 5y equals 3. 2x minus 3y is equal to 7. Okay? So, like I said, we're just going to add these two equations together. Right now, if I just do it at this moment, then I get a 6x, right, and a 2y, and a 10. I have not eliminated anything, so I obviously have not done my process correctly. Okay? We are going to add, but when you add it, it's supposed to eliminate. Oh, yes, we've done this before. You are supposed to eliminate something. So your job is to look at what you have here and determine whether you want to eliminate the x's or the y's. And my advice to you is to do it that requires the least effort possible. Now, the way that you eliminate, well, let's just talk about that for a minute. If I had the number 3 and I wanted to add something to it so that I got a 0 out of it, what would I add to a positive 3? Negative 3. And what would I add to a negative 17? Positive 17. So, as you can see, I need these two numbers that are coefficients in front of my variables, on at least one variable, to be the same number but different signs, and it would eliminate it, right? So, what could I get rid of very easily here? The x's. And I could make this 2 into a what? I don't want it to be a positive 4. I want it to be a negative 4, because the 4 that was already there is positive. So if I multiply through by negative 2, I'm going to have this set up so that I get a 0 pair. So the first equation stays the same. And my advice to you is to totally rewrite it over to the side so that you can have everything nice and lined up. If you don't do that, you're going to start having problems, especially when we get to 5.4. Or no, it's 5.2, I think. Well, both of them. Okay. Now the next one, the only thing that people forget is that that negative 2 has to be multiplied by 2x and by the negative 3y and by the 7. People forget anything is they forget to come across this equal sign with that. So that becomes negative 4x plus 6y is equal to negative 14. Everybody see you've got to distribute it through the entire equation for it to, otherwise you've just, given one thing. Remember the balanced pans, where you got the equation? Did y'all do that in elementary school? And like if you put something on this side, what do you have to do to this side? Put the same amount so it keeps it balanced. So if I'm multiplying by negative 2 on this side of the equation, I have to multiply by negative 2 over here, right? All right. So here is a 0 pair, which is what we were hoping for, right? We hadn't got that somewhere, we'd been in trouble. And we got 5y and 6y gives me 11y. And 3 and a negative 14 gives me a negative 11. So dividing by 11 tells me that y is equal to negative 1. Now, am I finished with this problem? Because I've got to find the x to go with it. Now, how do I find the x's to go with any y? In one of these two equations, right? Doesn't really matter which one. Well, I don't care. You all use the top one or the bottom one. The top one. So I've got 4 times x plus 5 times negative 1 equals 3. They slammed that one pretty hard, didn't they? Wasn't playing. They wanted it to connect. All right, so we got 4x minus 5 is equal to 3. And then we've just got a two-step equation, right? We're going to add 5 to both sides. So 4x is equal to 8. And dividing by 4 gives me x is equal to 2. So my solution for this system of equations is the point 2, negative 1. That's the place where they're going to intersect if you drew them. So any questions about the addition method? You really ought to. Just a good work habit to have. Okay. So any questions? Now what's important with this addition method? Somebody look at my next example and tell me what's important about my addition method. Oh, I need stuff lined up, don't I? And it'd be real nice if the X and Y were over there on one side. Yes? So I'm going to make this one, I'm going to turn this one into 2X minus 3Y is equal to 9. Right? Then I'm going to pull that to the other side and I get 3X plus 4Y is equal to 8. So let's get it all lined up first, and then we can look and see what I can multiply through by to get rid of stuff. I just moved the X's and the Y's all on the same side of the equation and lined them up. Because if you're not real careful, if you just glanced at that, you might think, oh, I can add those two together because I got a positive 3 and a negative 3, right? That would have been my zero pair, except for the fact that one was a Y and one was an X. Okay, so you got to be real careful and get them lined up so that you can see better what actually you can add together to get rid of the variable. This is one of the ones where you can't multiply by just one number. You've actually got to multiply both of them by something. Doesn't really matter. We could get rid of the Y's. We multiply the top by positive 4 and the bottom by positive 3. Does everybody see why I did that? Because the Y's already set up so that one's a positive and one's a negative to start with. And I don't have to worry about signs. Okay? I could get rid of the X's. I just got to make sure that I multiply one by a negative and the other one by a positive. Does everybody understand? There's no exact way to do this. You're going to get the same answer, but there's lots of different approaches to it. Well, not lots, but there's several. So if I do it my way, I get 8X minus 12Y is equal to 36, and 9X plus 12Y is equal to 24. Everybody else get that when they multiplied through? Make sure my multiplication skills aren't killing us today. Now, do I have it set up to where I can add it and eliminate something? Yes. The Y's are going to go away, right? My zero pair. And so I get 17X is equal to 60. Is that what y'all get? And then we divide both sides by 17. So X is equal to 60 over 17, which is kind of an ugly number, but we got it right there at the end, so it's not really a huge deal. Now, somebody needs to double check and make sure that I didn't mess up. But I think I wrote it down right. Somebody in the other class was like going along checking the answers in the back. You know, these checkpoint answers are in the back where you can check it. And I had the wrong answer. Because I'd taken part of the problem from here and part of it from here, and I plugged the wrong thing into the wrong. Yeah. So, it's always good to double check me. We're all human and we all make mistakes, huh? Okay, so we're good here. Now what do I have left to do? I got to solve for Y. And so I've just got to go back into 1, and I would go back into, one of the original equations before you start moving anything around. So I'm going to take this one that says 4Y is equal to 8 minus 3 times 60 over 17. So this is already solved for Y, except for the fact that I'm going to have to divide by 4 at the end, right? So I get 4Y is equal to, I don't know, y'all going to put it in improper fractions. What's 8 times 17? Is that like 136 or 126 or 136? So I got 136 over 17. So I turned the 8 over 1 into something over the 17 that I have already, right? Minus, now 3 times 60 is 180 over 17. Remember when you multiply, top times top, bottom times bottom? Everybody good with what I'm doing? All right. And so I have 4y is equal to a negative, what is that, 44 over 17. And then I got to divide by 4. That's the same thing as multiplying by 1/4, right? So y gives me a negative 11 over 17. So what you got when you, has anybody got their little thumbs working and checking me? Did y'all forget y'all were supposed to be checking? I'm sorry. Yeah, that's right. All right. Any questions? You do get fractions, but you kind of get them at the end, so it's really not a big deal. So don't get all upset about having fractions there. Now, the fourth objective says that sometimes I get systems of equations that get different amounts of answers. Because we have sometimes that we have systems that have no solution. Or infinitely many solutions. Anybody remember this piece? Let's think about it. What have we got? We've got 2 lines, right? All of these are linear equations, so they're just lines. So we've been talking about what happens when I have 2 lines that actually intersect, right? You get that one solution that we've been getting. What's something else that can happen with 2 lines? Do they have to intersect? They could be parallel. If the 2 lines were parallel, they would have how many solutions? They would have no solutions because they're not going to intersect. There's never going to be a point that makes this line true and this one, right? Never a point that you can put it into both of them and both of them are going to make true statements, right? Because they don't ever meet. So what am I looking for with parallel lines? Does anybody remember the definition of parallel lines? They would have the same slope, but different intercepts. That's exactly right. Same slope, different intercepts. I want you to think about what that would look like as far as an equation goes. Can somebody tell me, can somebody give me an example of a couple of equations that would be parallel lines? Okay. Pretty creative, but everybody see what he's talking about? Same slope, different intercepts. Now, what about if it were in standard form, where it wasn't solved for y, the x and the y were on the same side of the equation? Okay, what if I told you it was 2x plus 3y is equal to 4? Can you give me another equation that's going to have the same slope but a different y-intercept? What? That's exactly right. For them to have the same slope, these coefficients here have to be the same numbers or multiples of the same number. Could be multiples, right? I could have had a 4 and a 6, because then when I multiply through by 2, can you see I would have the same thing? Coefficients, they either have to be the same or multiples of the same numbers. So I could have also had 2x plus 3y is equal to 4, and 4x plus 6y is equal to 10. Because this is going to reduce to the same 2/3, negative 2/3. But it'd be 5. Yeah. Okay? So that's what I was talking about. Could be some multiple. All right, and then there's one other type of solution that you can have, and it's infinitely many solutions, and that's when you have 2 equations that actually represent the same line. It's actually really just the same line in disguise. So if it's the same line, then any point that works for one line will also work for the other line. That's why it's infinitely many, because every line is made up of infinitely many points, right? So that's going to look something like 2x plus 3y is equal to 4. I was jumping ahead. And 4x plus 6y is equal to 8. They look like different lines. But if you solve that, or you multiply this one through by 2, you'd see that you'd get 4x plus 6y is equal to 8. So they're really the same equation. They're just ones in disguise. Okay? It is very easy. But you have to remember this, because every single year I have somebody who goes, I don't know what to do with these. There's nothing to do, right? You can't solve it because it's not going to do anything. Now, if, you forget what it looks like and you don't notice that this is the same line, we need to talk about what's going to happen. So let's just take our example there, our 2x plus 3y equals 4, and the 4x plus 6y equals 8. And let's pretend like you didn't notice it. So you are going to do the elimination method, okay? So we're going to take that top one and multiply through by negative 2, right? So we're going to get rid of x's. So I got negative 4x minus 6y equals negative 8. And then the bottom one is 4x plus 6y is equal to positive 8. And then look what happens. And you get 0 equals 0. Okay? When you get that 0 is equal to 0, that means that you have the same line in disguise, so you have infinitely many solutions. Okay? All the points that fit, that satisfy the equation 2x plus 3y equals 4. Infinitely many solutions, yes. That's what you're going to write. Now let's think about that other example we talked about where we had 2x plus 3y is equal to 4 and 2x plus 3y is equal to 5. That one that y'all gave me a while ago. Let's say you didn't remember that that's parallel lines because you didn't think about it, because you're just busy. You've done 25 of these problems and you wasn't thinking ahead. You're just cranking them out, right? So you'd look at this and say, okay, to get rid of x, I'm going to multiply through by negative 1. So I got negative 2x minus 3y is equal to negative 4. And then 2x plus 3y is equal to 5. Okay? We good? So that's a 0 pair. That's a 0 pair. So I get 0 is equal to 1. That is not a true statement, right? 0 is not equal to 1. So that would tell you that this is a no solution problem. They're parallel lines. Okay? So in case you didn't recognize it to start with and you actually did go ahead and do the work, I want you to see what the answers look like. But you don't have to do any work. If you see it up front, you look at those slopes and you see that what's going to happen, you can just go ahead and write for me right then, no solution. I don't have to see any work on it. Okay? Any questions? These types of equations have names. Okay, we can classify these types of systems of equations. The ones that have one solution are called consistent. Consistent means that they have a solution. And they're independent. Independent means they're actually two different equations. Okay, so they're consistent and independent. Two different categories that I can categorize these into. If they have one solution, they're considered consistent equations. It is a consistent system of equations, and they are independent equations. Okay? If there's no solution, then it is inconsistent. It's not dependent, though. Remember that consistent and inconsistent. Consistent means it does have a solution. Inconsistent means it doesn't have a solution. Okay? So it doesn't have a solution. Remember, dependent means it's actually the same line, and independent means it's two different lines. So they couldn't be parallel if they weren't independent. Okay, so it's got to be independent. So this one is inconsistent and independent. And then we have the one with the infinitely many solutions, where it's actually just one line in disguise. So of course that's definitely dependent, right? Because that's what dependent meant, was it's really the same line. But let's talk about consistent or inconsistent. Which one is it? Does it have a solution? Yeah, it's got a whole bunch of solutions, so it's definitely consistent. Okay? So those are the categories. Are we good? Okay, I want to give you one more example. It's not in the book. Let's say that I have an equation x plus 2y is equal to 4, and 3x plus 5y is equal to 10. Okay? I hope I made that up right. Made that one up on the fly, but I wanted y'all to see something. On the fly, yeah. All right, so what's my easy way if I'm going to do this by elimination? Well, do y'all want to do it by substitution? I've done lots of eliminations. I haven't really done. You can do this one by substitution. All right, so this one works nicely for substitution because I have that x, right? So I can do x is equal to negative 2y plus 4, or 4 minus 2y, however you want to write it. Okay? And then once I get one equation solved for an expression, then I'm going to take that expression and put it in the other equation. Yeah. It's just if you don't have one that's got a coefficient of 1, you may wind up with a fraction in there. See, like right here, you'd have a 5/3. If you solved it for x, you'd have 5/3 y. And you'd have to be working with fractions. I never do it unless there's at least one variable in there that's got a coefficient of 1. Otherwise, I just use the elimination method. That way I don't get the fraction until the very end. All right. And so we distribute here. We get negative 6y plus 12 is equal to 5y. How about plus 5y is equal to 10. Then I can combine like terms. So I get negative y plus 12 is equal to 10. So negative y is equal to negative 2. So y is equal to 2. Okay? And then plug it back in. So I get negative 2 times 2 plus 4. So x is actually equal to 0. 0 is a possibility. I have a lot of people, it more often happens when I do the elimination method. But if it comes down and it says x is equal to 0, do not think that that means the same thing as when we got 0 equals 0 or 0. See, I had a 0 equals 0 or 0 equals some other number. Okay, if 0 is equal to x, then it just means the coordinate of x is 0. Okay, so anytime you see a 0 in your solution, don't automatically think that it's either infinitely many solutions or no solutions, okay? Because this ordered pair right here is the point 0, 2. Okay, just wanted to remind you of that. It always happens that somebody comes down here and x is equal to 0 and they go, oh, does this mean I've got no solution? No. If it says x is 0, you're good. That just means x is 0. What you'll get with those inconsistent and dependent solutions is that there will be no variable left. It'll just say 0 is equal to 0 or 0 is equal to some other number. There won't be a letter there. Everything will cancel out except for number parts. Okay, so just know that there's a difference. If it says x or y is equal to 0, that just means that coefficient is 0, and you're good. Just keep working and find the next one.
So if you do it like with a substitution, you'll still find the resolution, correct? So it'll be like negative 3y plus positive 3y. And then
It'll all cancel out and give you 0 equals some number or 0 equals 0. Yep. Yep, that's why I was saying, just be real careful because I see that a lot, that people grab a hold of that idea so well here, which is good, but then they do one of those substitutions or an elimination method, and it comes up and it says x or y is equal to 0, and they go, oh, I'm done with this because it's got no solution. Okay? Any questions about that? Then the last thing that's in this section talks about break-even analysis. It's an application of this in the business world. In the business world, many times we want to talk about a profit function. This is objective 5, the last objective in this section. Not profit function, I don't know where. The revenue function. And a cost function. Now, we need to make sure that you have the vocabulary here. What does revenue mean? It's how much money you made. Is it profit? Is there a difference between revenue and profit? Yes. After all your spending. All right, so as long as y'all all know that, because a lot of times I have a lot of people who don't understand the difference between profit and revenue. Profit is revenue minus cost, right? Because revenue is just all the money you're going to get in, regardless of how much you had to pay out to keep your company going, or how much it costs to build the thing to start with. And then, of course, the cost function is just all of the factors that are involved with making this product. The break-even point is when the revenue and the cost actually meet. Like, when am I finally going to get enough revenue that it's going to pay for doing this? Let's say you decided that you were going to go into business selling T-shirts. Okay? Or you're going to have a school fundraiser. You're going to sell T-shirts. Right? You sell the T-shirts for $10. There was a setup cost of $50, plus it cost you $6 for every T-shirt that you ordered. How many T-shirts do you have to sell to break even? Because, I don't know about y'all, but my group went in a hole on our T-shirts because we didn't sell enough of them to pay the cost of ordering them to start with. So that happens a lot. So it's when the revenue is equal to the cost. So what's this going to turn into? So we said our revenue function was $10 per shirt, right? And our cost was $50 plus $6 per shirt. Yes? What does R of X and C of X usually get replaced with? Y's, right? That's my Y value. So my equation is Y is equal to 10X and Y is equal to 50 plus 6X. Do you see why we talk about this in this section? What is this? A system of equations. And the break-even point is the solution, right? Yes. Always one of these on the ACT. At least one. Okay? Now, We have a couple of choices about how to solve this. I could move the x's to the other side and do elimination, right? Or I could do substitution, right? I mean, it's already solved for a variable, isn't it? So I could take this variable, this expression for y and plug it in for that y. So I get 10x is equal to 50 plus 6x. Does that make sense? Okay. I took this expression that I know y is equal to, and I put it in for the y down here. I just put it in for the y. Y happened to be sitting there by itself, so it looks a little different than it's been looking. But it's actually an easier problem than we've been doing, right? Okay. And so then I want to solve this, so I've got to subtract 6 from both sides. So I get 4x is equal to 50. And divide by 4. So I gotta sell how many shirts before I get to the point where it's not costing me something? 13 shirts, right? Gotta sell 13 shirts, or it's gonna cost me to have done these shirts.
So if you get like x equals 12.5, you just write 13.
Yes, if you're talking about a business application like this, then yes, you do have to round up. Okay? All right. And then, like I say, the other thing that you need to know here is that profit, that's the money that's left over. So the profit function is always found by taking what? The revenue function minus the cost function. Okay, so it's always revenue minus cost. So like I say, for those of you who are in economics, y'all got that already, right? All right. Any questions? That's all of this section. Okay, the homework assignment, again, is page 502. Four through 84, multiples of 4. Okay, is that good?